Hello. So in this video, we're just going to continue reviewing our 6 trigonometric functions. So by now, you should already have all 6 of them memorized. Remember, a function means you plug in something, an input, and you get out an output. So with a trig function, if you remember, we have sine, cosine, and tangent. And these are functions. So what you're going to input into the function is an angle. And that angle could be any angle, really. So you could say theta, theta, theta here. Okay? You don't have to put the parentheses, and a lot of times you'll see problems without parentheses. Parentheses are going to be more useful if you have more complicated inputs. But what you're going to get out of this, the solution to a trig function, is the ratio of two sides of a right triangle. So theta is an angle inside of a right triangle, okay? And looking at this right triangle, we have three sides. We have the opposite side, the adjacent side, and the hypotenuse. So when you're inputting the angle theta into these trig functions, your output or your solution is going to be the ratio of two sides. So for theta, the solution to sine of theta is going to be the ratio of the opposite over the hypotenuse side of the triangle. For cosine, it's going to be the adjacent to the hypotenuse side of the right triangle. And again, these sides are adjacent to the angle theta, of course, and the hypotenuse of the right triangle. And tangent theta is going to be the opposite, is going to be the ratio of the opposite to the adjacent sides to theta in this right triangle. Now, there were three others, which were essentially just the reciprocals of these three main trig functions. So if you remember here, the reciprocal of sine is cosecant, and that is hypotenuse over opposite side. The reciprocal of cosine is secant, and that would be the ratio of the hypotenuse to the adjacent side to theta. Again, you don't have to put parentheses if you don't want to. It's not that important for these problems. And last but not least, the reciprocal of tangent is cotangent. And looking at theta, that would be the adjacent over the opposite side. Okay? And those are our 6 trig functions. So by now, these should already be ingrained in your minds. What we're going to be looking at in this video now is slightly more tricky and complicated problems that we may run into when it comes to figuring out our trig functions. The first type here is if you are given a right triangle with only two sides. So let's take, for example, a triangle like this. A right triangle like that. And I wanted to find sine of theta. Okay? So the opposite side to theta is 2. So at least we have the numerator to sine. But our problem here is we don't know the hypotenuse. Our hypotenuse is missing. What in the world is this hypotenuse? Now, it may seem scary, but we actually have enough information to find out what the hypotenuse actually is. So, if you have a right triangle and you know two of its sides, you can find its third side with the Pythagoras theorem. So, using the Pythagoras theorem, 2 squared plus 5 squared would be equal to question mark squared, which is what we're looking for. So we have here 4 plus 25 is equal to question mark squared. And then 29 is equal to question mark squared. Therefore, our missing side, our hypotenuse, is square root of 29. Now, some of you may be asking, well, wouldn't negative square root of 29 also be a solution? Technically, mathematically, yes, negative is a solution to this equation, but there's no such thing as a negative length. So we only focus on the positive length. So we have figured out here that the hypotenuse is actually square root of 29. Therefore, we can now find out that sine of theta is square root of 29. And that is our ratio. How about now if you wanted to find secant theta? So if you remember, secant is the reciprocal of cosine. So that means it's going to be the hypotenuse over the adjacent side. So square root of 29 over 5. There you go. So if you are ever missing a side of a right triangle, all you need to do is use Pythagoras' theorem to figure out the missing side. So let's do this problem here. What is tangent of theta? So if you remember, tangent of theta means the ratio of the opposite side to the adjacent side of angle theta. So here's angle theta. We have the hypotenuse. We also have the adjacent side to theta, but we are missing the opposite side to theta, which we need to find tangent. So if we use Pythagoras' theorem, we would figure out that 2 squared plus question mark squared equals 5 squared. You don't have to use question mark. You could use x or a as other variables if you don't want to use question mark. It doesn't really make a difference at the end of the day. So 4 plus question mark squared equals 25. So question mark squared equals 21. So question mark, or the opposite side, is square root of 21. And now we know the opposite side. So tangent theta is opposite over adjacent. And there you go. That is the solution to this problem. Okay, so here I'm giving you a right triangle with only 2 known sides. So, looking at angle theta, find all 6 trig functions to that angle. Pause this video and attempt to do this problem on your own. When you start the video again, the answers will show up in a few seconds. And there you have it. If you have done your calculations correctly, you would have found that the adjacent side to theta was square root of 11. Therefore, now that you have all 3 sides of this right triangle, you can find all 6 trig functions to angle theta. Another trick question that you may be asked is an example like this. Find cosine of alpha minus 90. So you may start panicking here, but if you remember, this is essentially the complementary angle to alpha. And if you remember, the complementary angle to alpha, in this case, would be right here. This angle right here in blue is alpha minus 90 degrees. So if you wanted to find cosine of alpha minus 90, that would be equal to the adjacent side to this angle, which is 2, over the hypotenuse of the right triangle, which is 7. So this would be equal to 2 over 7. So this is a trick way in which they ask you to find the trig function of the other angle in the right triangle. The last trick question that you may be asked is where they give you an already known trig function of an angle, and they ask you to find another trig function of that angle. So my advice for you guys would be to actually just draw the triangle. So again, when we're getting the trig function of an angle, we're assuming we're getting it of a right triangle. So you could just go here and just draw some generic right triangle with an angle theta. If they're telling us that cotangent of this angle is 3/4, what they're telling us is that the adjacent side is 3 and the opposite side is 4. Because if you remember, cotangent is the reciprocal of tangent. So that means it would be adjacent over opposite. So knowing this, now we can actually figure out what the missing side is. So in this case, the hypotenuse. So 3 squared plus 4 squared equals h squared. Therefore, h is equal to 5. This one's actually an easy one because the 3, 4, 5 triangle is a triangle that you should know already. But if you calculated it, you would get 5 as well. So, therefore, now you know that cosine theta has to be equal to 3/5. And that's the answer. So, to finish this video off, attempt to do these problems on your own. So pause this video and see if you can figure out what these trig functions would be. So pause the video, and when you start it again, the answers will show up in a few seconds. And there you have it. Here are the answers to these trig functions. For the first one, notice that the missing side of the right triangle was square root of 40. However, you should get into the habit of simplifying square roots as much as possible. So square root of 40 can technically be broken down to 2 square root of 10. So both of the answers shown here would be correct. But again, the simplified square root is the preferred answer. Number 2, the missing side of theta, which was the opposite side, was square root of 119, which couldn't be simplified, so we left it as is. So sine of theta would have been square root of 119 over 12. And last but not least, notice that I was asking what is the cosecant of the complementary angle. So cosecant is just the reciprocal of sine. So sine of the complementary angle would have been 5 over square root of 29. Therefore, cosecant, or the reciprocal, would have been square root of 29 over 5. So I hope this video helped. If you need to go back and rewatch the problems, go ahead and redo those. And keep practicing. You will get this in no time. So I will see you in the next video. Bye.